Okay. Hello everyone. Welcome back to my YouTube channel, the Kim Boy. So yeah, this is a very special content, Talk with ChE, where we will talk with someone used to be a chemical engineer, but today it is a very special one because it might be not coming from a chemical engineering background, but however, the research will be very related to us, chemical engineer, and here with us already Mr. Dirar Aletan. Hi, sir.
Hi, thank you.
Okay,
Thank you.
so yeah, Mr. Dirar, could you give a brief introduction about yourself?
Yeah, sure. I started my background actually in mechanical engineering.
Oh,
I worked after I did my mechanical engineering a little bit in the mining and oil and gas industry. And then I pursued masters. I wanted to specialize in the oil and gas industry so I did masters in the oil and gas engineering at Aberdeen University in the UK. To further also my career aspirations in getting into research and development. I'm pursuing right now as a PhD in my senior year of PhD in Canada in petroleum system engineering as well, where I'm working in CCS, I'm utilizing nanotechnology to improve carbon capture systems.
wow, that's very great. By the way, where do you come from?
I'm originally from Jordan,
Oh,
from the
Jordan.
Kingdom of
Okay,
Jordan.
nice, nice, nice. And you're right now in Canada, if I'm not mistaken. Yeah.
Correct.
Nice, nice. So it's very interesting for me because you are coming from mechanical engineers, and right now you are very concentrating with the field of petroleum engineers, especially not the really common topics by the petroleum engineers mainly talking about like the hydraulic fracturing, about something related to the oil and gas field, but you are talking about CCS. So that's why for me, you're very interesting in this site. Next one is why do you choose to be in this specific path?
I was always been fascinated about energy itself, the energy, how it's produced, what the production of energy, the accompanied disposes of energy, and how we can have a sustainable system of our energy system itself. So, from a mechanical engineering background, I always look into the mechanical system in the energy industry and try to find a way for sustainable let's say a sustainable project itself. This is what I was always been fascinated about, to
Oh,
manipulate the energy system itself. So right now there is a huge rise in the oil and gas industry, specifically whenever in the oil and gas industry, in oil companies, big leaders in oil companies, whenever energy sustainability is the purpose of their project, it's always about CCS right now for a
yeah, yeah.
sustainable oil and gas fully project. And that's the outlook also based on my experience and based on my interaction in the oil industry. This is the outlook of the energy industry right now, the sustainability of energy industry.
Wow, that's very interesting one. Comes from a mechanical background and then have interest in petroleum and then talking about sustainability, it's definitely about CCS. So we will discuss deeper about that, about your research. So as I know that your research is about modeling of CCS using membranes, specifically you're using machine learning. So maybe you can give a brief about your research, please.
So most technologies right now for capture system, like the most dominant one, they're using chemical solvents. I mean chemical solvents,
Sure,
and those
sure.
chemical solvents they're currently used due to their high credibility because it's already in the market. It's reached its readiness maturity, and that's all. But technically, after many investigations because of my PhDs,
Yeah.
yes, indeed, that's the main purpose, and due to also it has a high capacity of CO2 capturing. But um, the thing is, it's highly expensive.
Mm.
It's highly
Yeah.
expensive to regenerate that solvent. It's highly
Yes.
expensive to build the infrastructure for it. So it's not very feasible for most of the customers. Most of the customers they are power plants or oil refineries and so on, and those or natural gas processing plants. Uh, but they have the problem with this big size of infrastructure that they need to install for the amine solvent, the current amine solvent technology for CO2 capture. So this is why many R&Ds right now, their main focus is to reduce that size and reduce that cost. And one of the biggest emerging technologies to do that are the membrane technology, which is, imagine, we have membranes in many infiltration system in many other processing plants.
Yeah.
But for CO2 capture, currently in the world, based on my knowledge, there is not in commercialized yet.
Yeah.
All in the research and so if you ever heard of the TRL, the TRL is like
Yeah.
the technology
Teknologi
readiness
readiness.
technology. So most amine-based technology right now, they already reached to TRL 9, which is the maximum in a commercialized state.
Yeah.
But
Yeah.
membranes and there is other technologies that are physical solvents or adsorbents, solid adsorbents. Those the maximum readiness they reach is TRL 6. So
Oh.
imagine that's a huge gap we need to
Yeah.
develop. If we reach there, we could fix a lot of the size issues that we talked about. Imagine a filtration system for CO2. That will be much simpler, not complex system, because amine solvents, they usually have huge sizes of towers and
Yes.
huge tanks for
Absolutely.
that. And that take a lot of space and economic issues. So membrane will solve a lot of issues in that. Also, our focus is about sustainability and our focus about environmental impact. The chemical solvent, they have a toxic waste they need to deal with after they finish working
Yeah.
with the
The
solvent.
solvent
They
itself.
need to,
Yeah.
yeah, when its life cycle is deteriorates, they need to get rid of it, and that's a toxic solvent to get rid of it.
True.
While most membranes, they are polymer based. So most polymer based are recyclable. That's one, and they're solid waste, so it's not toxic.
Yeah.
So that's the benefit of it. The problem with the membranes, it's about their capacity to reach the level of the capturing CO2 capacity with respect to the chemical solvents, the amine based ones. So this is my main focus. I want to improve that. I'm utilizing nanotechnology by infusing nanoparticles to manipulate the properties of the membranes, hoping to increase that capacity, the
Oh,
capturing rate of CO2. Also, another issue with the membranes is the thermostability in complex systems such as the oil and gas. It's very harsh environment, as you know.
yeah.
So also we would like to manipulate the thermal properties of the polymer membrane by infusing with nanoparticles, and many research studies showed that a great improvement. And this is what I'm investigating based on my own nanoparticle to create nanocomposite membranes, which is
Wow.
fusing nanoparticle with polymer to improve it.
Wow. Very interesting one. So,
Yeah.
having a nanocomposite membrane for CCS, it's already a very fascinating things, right? It's a very novel technology. And what I notice here, you are not stopped with that, but you're uh, reaching next level by having a neural network model. So, could you
Yeah.
explain what is in your mind to reach until that
So
level?
yeah, sure. So after I already start producing and manufacture my own nanocomposite membranes, and right now I'm doing experimental data in the lab scale
Okay.
to get some data on the performance of this nanocomposite membrane. How does it improve the polymer based membranes? And then we need to do some optimization study based on those data and try to industrialize in an industry scale. And this is where machine learning comes from. It's very useful to do that. By machine learning, we can get, especially A and N, as you mentioned, we can acquire those, let's say, that specific size of data in the lab scale and get huge data in
Mm.
industrial scale. And then from those data, by mathematically modeling this my own experiment, we could also then start to optimize it. And then you
Okay.
can manipulate and get more proof of that.
Oh, yeah. So to optimize and to increase the scale of your technology, machine learning will have a great role. Yeah. So I think that's a very good part for us also, Kemi, because yeah, we are always talking about big capacity. So what's the point if you have a technology that only able in a small capacity, right?
Yeah.
So yeah. So you will use the neural network model to have the performance model of the membrane, is it? And how it
Yes.
will react with
Optimize.
the changing of the properties that
Parameters.
you're given to. Okay, okay, very interesting one. So I'm very looking forward for your research because I think it will be very interesting, and I hope it will be commercialized one day. Because yeah, I mean using the chemical absorption is already a very common one for right now. So membrane will be very interesting. Uh, in my opinion, like yeah, if we can have a filtration of water using membrane, why not we can do it the same with CO2? So nice. So another one is we. I know that you are already focusing yourself to the CCS technology for maybe several years. Uh, so in your opinion,
Excuse me, could you repeat that? You were cutting.
okay, okay, yeah,
Connection.
I got it.
Yeah.
So yeah, from what I see, you have quite deep research in the CCS technology. You are maybe already benchmarked to another process, yeah, what types of CCS technology are right now, by the current state of how CCS works. Do you think CCS technology is make any sense to you, and do you think it will be a common technology in the future, especially in the oil and gas industry?
So I do believe after many investigation for that, getting in deep, very in deep into carbon capture system, the carbon capture technology will not be just to it's projected not to be just to aim for CO2 emission, which is a very important issue. Yes, we want to reduce CO2, but thankfully also the CO2 capture can be used in many other areas, and it's the need to adapt and start reducing CO2 emission. It's led us to new path for utilizing CO2. The utilization CO2 is magnificent path right now we're going to. Specifically, uh, imagine, okay, many people would argue that CCS currently have been produced as an energy transition tool. But based on my investigation now, it starts to emerge as not just energy transition, even after energy transition. Uh, because many of the utilization of CO2 now emerge, such as hydrogen production. We can utilize CO2 separation from methane gases to increase hydrogen production, which is the high utilization of hydrogen. The main problem with it is increasing the production of hydrogen. It's very expensive, and it's integrated in its system to separate CO2 just to produce hydrogen from natural gases. Um, when we and the increase the production of hydrogen is it has a huge impact on the energy transition, because the one of the biggest role of after energy transition is hydrogen. It's play a huge role in energy transition. It's accounted as one of the biggest sources of energy in the future
Yeah,
if we're ever reached, hopefully, for energy transition. So we will need CO2 separation to increase the production of hydrogen. That's one. Two, also a new utilization of CO2, it's like an inverse of hydrogen. We need to separate CO2 from methane mostly to increase hydrogen, to produce hydrogen
yeah,
in ammonia plants.
ammonium plant.
Uh, but now there's a lot of research. We get hydrogen from this is when we produce hydrogen from methane, we call it blue hydrogen. And there is a green hydrogen where we produce hydrogen from green products, from renewable energy, from water, and so on.
Yeah.
And now there's an inverse reaction research is conducted, and it's successful by mixing. Imagine an inverse reaction where we get that green hydrogen with the captured CO2 that we start to capture. This is a new utilization path for CO2. We mix them to produce and synthesize methane, ethanol, and so on, and many other chemical hydrocarbon products, and kerosene, and so on. And it's successful projects, by the way. And there are some plants right now. They're actually they were successfully producing, synthesizing in the lab ethanol and methane. Imagine methane itself, natural gas. That's a huge also path and future for the utilization of carbon. So it's a whole new system right now is integrated and for the utilization too. It's like in my view, I start to project that there will be a huge new market in the world, which is CO2 market. People eventually will start see, okay, CO2 is a new product that we need to utilize, capture, and sell.
Wow. So CO2 will not will waste anymore, but will be a huge market. Yeah. And I get the point that you say that CCS is not only for energy transition, but we can use it in other ways. Yeah. Many process that use that capture, and might be the membrane will works in some case. So, a very interesting talk with you, sir. So, maybe to close our interview right now, we know, right, this sustainability topics right now is very hot topics, and yeah, many youngsters like me want to reach or want to have that specialty. So, do you have any message for the viewers of this video?
Yeah, so sustainability as a term is actually mentioned to it's to to sustain our global Earth that we all share. That's the main goal of sustainability. Even if we utilize that term on energy systems and oil and gas and chemicals and even in medical, whatever the field that you are in, we can all work together into sustainability and reach the goal of sustainability by conserving our Earth. Not just that, many people will say and would have a challenge with the sustainability of as a term because they would in specific fields around the world they will argue that okay, but it's affecting our profits, and then it will be profit versus morality, the biggest debate in the industry. But sustainability itself, it starts because of human nature is always evolving. Now it starts just like what we mentioned right now. We can utilize about those new aspects of sustainable technology to also increase our profit, not just to meet the morality of sustaining the earth, our global system. And I would encourage many of the youngster everywhere in the world to focus on that exactly, just how the concept that we just mentioned. Yes, it was the goal first to reduce CO2 emission, but then now we start to utilize CO2 and we increased. We're right now we're in the emergence of having a new market to the world, and new also where you can also profit. And then whatever anyone who's struggling with the morality of sustainability, you could encourage them by going and focus on optimizing and improving those kind of sustainability technologies.
Wow, a very good message. I believe that viewers will get many insights from these talks. Thank you very much, Mr. Dirar, for the talks we have, this discussion. For me, myself, I got many things from you. So yeah, I hope the viewers too. And it marks the end of our discussion for this episode. If you like this video, don't forget to share and like and subscribe also to this channel. And we'll see you guys in the next episode. Bye bye.